Okay, it is a plough which cut the turns in some cases and breaks the furrow slice by means of separately mounted large steel disc. And this plough is designed with a view to reduce the friction by making a rolling plough bottom instead of sliding plough bottom. And disc plough works well in condition where the motor does not work satisfactorily. This is the agriculture disc plough. You can see the two bottom and three bottom disc plough. This is a disc plough, three bottom disc plough. Here it is the scraper is provided to remove the mud attached on the disc. So advantage of the disc plough can be forced to penetrate into the soil, which is too hard and dry for working with a moldboard plough. It works well in a sticky soil in which moldboard plough does not score, and it is more useful for deep ploughing, and it can be safely in a stony and scumpy soil without much danger of the breakage. A disc plough works well even after a considerable part of the disc is worn off in abrasive soil. It works in a loose soil such as a pit without much ploughing. Disadvantage of the disc plough: it is not suitable for covering the surface slash weeds as effectively as moldboard plough does. Okay. And comparatively, the disc plough leaves the soil in a rough and cloudy condition, and then that of the moldboard. The disc plough is much heavier than moldboard plough. For equal capacity, because of penetration of the plough is affected largely by its weight rather than suction. And there is one significant difference between the moldboard plough and disc plough. The moldboard plough forces into the ground by the suction of the plough, while the disc plough is forced into the ground by on its weight. The term connected to the disc plough, disc, it is a circular concave revolving steel plate used for cutting and inverting the soil, and it is made up of the heat treated steel of 5 to 10 mm thickness. The edge of the disc is well sharpened to cut the soil. And disc angle, it is the angle at which the plane of cutting edge of the disc is inclined to its direction of the travel. Usually disc plough is a good plough varies between 40 to 45 degree, and tilt angle, it is the angle at which plane of the cutting edge of the disc is inclined to its vertical plane. Usually tilt angle of the good plough varies between 50 to 25 degree. The tilt angle, you can see a disc angle. So we will get the idea what I mean by the tilt angle and disc angle. So a scraper, it is devised to remove the soil tend to stick to the working surface of the disc. Concavity is the depth measure at the center of the disc by placing its concave side on the flat surface. Tactodon disc plough weighs between the 180 to 540 kg per disc, but the animal drawn disc plough weighs about 30 kg per disc. Okay. The disc plough are broadly classified as standard disc plough, animal drawn or tractor drawn, and vertical disc plough. Or this is a standard disc plough. You can see the adjusted levers, standards, manframe, furrow wheels. Okay, disc scrapers. This is standard disc plough. A steel disc 60 to 80 cm diameter set at a certain angle to the direction of travel. And disc is made up of the heat treated steel 160 inch by 3 by 8 inch thick edge of the which is a well sharpened. And concavity varies of the disc diameter is 3 inch to inch for 24 inch diameter disc and 6.5 inch for 80 inch diameter disc. The scraper is provided to remove the soil that tend to stick to working surface of the disc, and each disc revolves on a stub axle in a thrust bearing carried at the lower end of the strong stand bolted to the plough wheel. And mounted type, this is the side thrust is taken by the wheel of the tractor, or sometimes rear wheel is fitted to take the side thrust. Trail type, side thrust is taken by the furrow wheel. This is the vertical disc flow. It has a hitch point, adjusting lever, mainframe, disc. Vertical disc flow, it combines the principle of regular disc flow and disc harrow, and used in shallow soil working in the soil that is 3 inch to 4 inch deep. It consists of the frame, wheel arrangement, depth adjustment device, or standard disc flow, but discs are fitted on a single shaft and turn as an in it. And the diameter of the disc is smaller and varies between 50 to 60 centimeter. And disc angle ranges between 35 to 55 degree. And it may be 2 to 32 disc space of the 30 centimeter apart. All discs are fixed to throw the soil in one direction. And this flow is preferred in a wheat growing areas. By decreasing the tilt angle, penetration is improved in standard flow. By increasing the disc angle, penetration is improved, but the width of cut is reduced. By adding the weight of the flow, penetration is increased. And the disc should be well polished and sharp. The flow wheel should be properly adjusted to keep the flow operating level. The angle between the frame and land wheel axle be adjusted for required width of cut. Now this is the defect and reason for the remedies. Now the other flow, the chisel flow, it cut the through hard soil by means of the number of narrow tines, and it is useful for breaking up the hard layer of the soil. This is subsoiler. It is a chisel flow with single tine, and it penetrates up to the 100 centimeter depth or more. Then rotary flow, it's a flow used to cut and pulverize the soil by impact force by means of numbers of rotary tines or knives which are mounted on a horizontal rotor. And it is also useful for distributing and mixing the organic matter and other material throughout the field. It pulverizes the soil actually. This is a rotary tillers, and it also part as a rotavator. Other flows is a rotating auger flow. It flow with the short flow bottom followed the vertical rotor having plates. Now the problems on this that is determine the horsepower required, a full of 4 bottom 32 centimeter flow working to the depth of 40 centimeter. The tractor is operating at speed of 5.5 km. The soil resistance is given 0.8 kg per centimeter square. So this is the solution. Total width of plowing is equal to width of one plowing into numbers of plow bottom, that is 32 centimeter is given into 4 of bottom, therefore 128 centimeter. The furrow cross section is total width of plowing into depth of plowing, so we will get the 1792 centimeter square. And total draft is equal to soil resistance into furrow cross section. Here given the soil resistance 0.8 into multiplied by the furrow cross section, we get the 1433.6 kg. This is the drawbar horsepower is equal to draft into speed upon 4500. The calculation we get the 29.202 drawbar horsepower. Now problem second, calculate the area covered per day of the 8 hours of tractor. For bottom 35 centimeter flow, if the speed of the flow is 5 km per hour, the time lost in turning is 10%, and so calculate the time required to cover the 1 hectare area. So calculate the area covered. The area covered per hour is 4 into 35 by 100 into 5 into 1000. We get the 7000 meter square. And the area to be covered in 8 hours, that is 7000 into 85600 meters square. We get the 5.6 hectare. The turning loss is calculated 10%. We get the 0.56 hectare. Actual area covered in 8 hours. We get the minus the that is 5.6 minus 0.56. We get the 5.04 hectare. Actually, area covered in 1 hour is 5.04 by 8 hours. So we get the 0.63 hectare in 1 hours. The time required to cover the 1 hectare area, 1 by 0.63, we get the 1.5, it's 7 hours. Again, in this way, we also solve the same problem, that is total draft of for bottom 35 centimeter MB plow when plowing 80 centimeter deep at 5 kilometer speed in 1600 kg, and calculate the unit draft in kg per centimeter. So, what is the actual power requirement? And if the field efficiency is 75%, what is the rate of doing work in hectare per hour? So in this way we calculate the first unit draft, then rubber horsepower, then rate of works. Okay. Then same way we also calculate the problem number 4, problem number 5. Thank you, dear student. We stop here.